Okay. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to do our group presentation for our project. Me and my friends will discuss the investment of different hospitals on buying different devices. Now I'll start. I'm Abdullah Ala, and I will start with Dr. Salman Faqih Hospital and their investment on buying a new ultrasound imaging system. So first, Dr. Salman Faqih Hospital is a leading healthcare provider in Jeddah, Saudi Arabia. So the hospital is committed to provide patients with the highest quality of care, and they continuously invest in new technologies to enhance their services. And now in our project, we're assuming that the ultrasound imaging system is outdated and no longer meets the needs of the surgeons and staff. So here we listed the benefits of having a new ultrasound imaging system to show the importance of this investment. So it will improve the image quality for accurate diagnosis. It will give a wider range of applications for diverse patient needs, advanced elastography capabilities for tissue stiffness assessment, user-centered design for comfort and efficiency, easy-to-use interface to simplify the operations. Okay, now we will discuss the technical specifications that should be met in all the possible ultrasound imaging systems. So with the resolution, it should be 0.08 millimeter or better. Number of channels should be 16 or more. Transducer frequency should be from 2 to 12 MHz. Elastography capabilities is essential. Elastography design should include adjustable controls, swiveling monitor, and comfortable patient table. Easy-to-use interface with touchscreen display and intuitive menus. Durability with the water resistance and dust proof and shock resistance. Okay, with the vendor evaluation, we're assuming that we received 3 different proposals from 3 different vendors for the new ultrasound imaging system. We assessed the proposals based on the following criteria: technical compliance with tender specifications, price, delivery time, vendor reputation, service, and support. Okay, here with vendor comparison, we can see here we have 3 different proposals from 3 different vendors. Each criteria shows the positive and negatives of the offered ultrasound imaging system. So here we can see with the 3 choices, 2 of them meets all the specifications, while Siemens meet most of the specifications. But at the same time, Siemens provide the cheapest price and the longest delivery time, which is a good thing, which is a bad thing. But by comparing with Philips, we can see they meet all the specifications. Their price is reasonable. Delivery time with the shortest delivery time. Vendor reputation is excellent. Service and support with 24/7 support. So after reviewing all the 3 proposals, we recommend selecting Philips Healthcare as the primary choice for the new ultrasound imaging system. As I said, because it meets all the hospital requirements, offers additional benefits, and the vendor has a good reputation. So in conclusion, the investment of buying a new ultrasound imaging system is a critical investment even for a big hospital like Dr. Salman Faqih Hospital. And based on the information we provided in this presentation, Philips Healthcare provide the best proposal for ultrasound imaging system to the hospital. Okay, now with other colleagues to review another device. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ahmed Al-Garni, and now I'm going to represent the nuclear tomographic imaging single photon at-based emission tomography. First of all, let's learn what is the nuclear tomographic imaging. Nuclear tomographic imaging like SPECT, single photon emission tomography, and PET, positron emission tomography, uses radioactive substance to capture detailed image of internal body structure and function. SPECT focused on gamma rays emitted by radioactive substance, while BET detect positrons emitted by a tracer material. Both methods create 3D image that help detectors diagnose diseases and disease organ function by mapping the distribution of this radioactive substance in the body. Now I'm going to show you the table of feature of the nuclear imaging thermographical. The first column we have SPECT and the second column we have BET. In the first in the first feature we have imaging principle. In the SPECT we have detects gamma rays emitted by the radio takers, and the other one is detects positrons emitted by radio takers. Now the second feature is radioactive substance use. In SPECT we have gamma emitting isotopes, and other one is we have positron emitted isotopes. And the third feature we have image resolution. In the SPCT we have lower resolution. In the second column we have higher spatial resolution. And the fourth feature we have functional imaging capability. First column we have profiles functional and anatomical information. And the second column we have excellent for functional imaging. In the fifth feature we have sensitivity. First column we have less sensitivity, and second column we have more sensitive for detecting subtle change. Now let's move to the sixth feature, which is clinical application. In the SPECT we have widely used in various medical specialties. In the BET we have commonly used in oncology, neurology, and cardiology. In the seventh feature we have radiation exposed. We have in the first column typical lower exposure, and the second column we have can involve higher radiation exposure. And in the scan duration we have in the SPECT longer scanning time. In the BET we have shorter scanning time. And the last feature we have availability. So in the first column we have more widely available, while in the second column BET we have availability may be more limited. Now, on the final part, we will do some evaluation on each device. On the image quality, in SPECT we have moderated image resolution and less detail, while on the other hand we have high resolution images and greater detail. On the sensitivity, on SPECT you have lower sensitivity and might be subtle change, while on the other hand we have high sensitivities, detect subtle change. On the functional information, SPECT you have provides function data and less detail, while on the other hand we have excellent for detailed functional imaging. On the radiation exposure, on SPECT you have generally lower radiation exposure, while on the other hand we have may involve higher radiation exposure. On the clinical applicability, we have in SPECT you have used in various medical fields, while on the other hand we have widely used in oncology, neurology, and cardiology. On the availability in SPECT you have more widely available in medical settings, while the other half we have availability might be more limited. The cost we have on the SBECT often more cost expensive compared to BET, while on the other hand we have generally high cost due to the technology. And the final thing we have scan duration. In SBECT you have longer scan duration, while on the other hand we have shorter scan duration. And that's all what I have on my part. Now, on the final part, we will do some evaluation on each device. On the image quality, in SBECT we have moderated image resolution and less detail, while on the other hand we have high resolution images and greater detail. On the sensitivity, on SBECT you have lower sensitivity and might be subtle change, while on the other hand we have high sensitivities detect subtle change. On the functional information, SPECT you have provides function data and less detail, while on the other hand we have excellent for detailed functional imaging. On the radiation exposure, on SPECT you have generally lower radiation exposure, while on the other hand we have may involve higher radiation exposure. On the clinical applicability, we have in SBECT you have used in various medical fields, while on the other hand we have widely used in oncology, neurology, and cardiology. On the availability in SBECT, you have more widely available in medical settings, while the other half we have availability might be more limited. The cost we have on the SBECT often more cost expensive compared to BET, while on the other hand we have generally high cost due to the technology. And the final thing we have scan duration. In SBECT you have longer scan duration, while on the other hand we have shorter scan duration. And that's all what I have on my part.
Hello everyone, my name is Hassan Sahir Amri and I will continue the presentation with the third device, which is breast imaging mammography. I will start with the introduction. In the introduction, breast imaging plays a crucial role in early detection and diagnosis of breast cancer. Mammography is widely used in imaging modality for breast examination, providing high resolution imaging of breast tissue. In this presentation, we will discuss the most important features needed for our local hospital in terms of mammography equipment selection. Provide a tender document with technical specification and consider comparison to make informed precious discussions. And then I will compare between three devices, and then I will select the best selection out of these three devices. Starting with the first device, which is GE Sonograph Pristina. In high image quality, the GE Sonograph Pristina offers excellent image quality with high resolution, superb contrast, and low noise levels, enabling accurate diagnosis. And then radiation dose. It incorporates advanced dose management technologies such as the GEASIR, which stands for Advanced Statistical Iterative reconstruction algorithm to minimize radiation dose while maintaining image quality, ensuring patient safety during screening and diagnostic procedure. And in the digital technology, the sonograph Pristina is equipped with digital mammography technology, allowing the efficient image acquisition and storage and retrieval. And then in the tomosynthesis capability, it provides 3D tomosynthesis functionality, offering a more comprehensive view of breast tissue and improving the detection of small lesions. And lastly, the comfortable patient experience. The device prioritizes patient comfort with its ergonomic design, rounded compression paddles, and comfortable arm rest, ensuring a positive patient experience. Second device, which is Siemens Mammoth Revelation, and the image quality, as like the first device, the Siemens Mammoth Revelation delivers high quality images with excellent resolution, contrast, and low noise levels, enabling accurate diagnosis. And then the radiation dose, it incorporates advanced dose management features such as the Siemens OP COMP, which stands for Optimized Compression Technology, to minimize radiation dose while maintaining image quality and ensuring patient safety. And then digital mammography. The Mammoth Revelation is equipped with digital mammography technology, facilitating efficient image acquisition, storage, and retrieval. And the tomosynthesis capability, similar to the GE sonograph Pristina, it provides 3D functionality, offering enhanced visualization of breast tissue and improving diagnostic accuracy. And lastly, patient comfort. The device features soft paddles, personalized compression, and soft mood light, enhancing patient comfort during the examination. Lastly, to our third device, which is Hologic Selena Dimensions. Starting with the image quality, the Hologic Selena Dimensions delivers high-resolution images with excellent contrast and low noise levels, ensuring accurate diagnosis like the past two devices. And in the radiation dose, it incorporates advanced dose management technology such as the Hologic Clarity HD, which stands for High Definition Imaging Technology, to optimize radiation dose while maintaining image quality, prioritizing patient safety. And then digital mammography, the Selena Dimensions is equipped with digital mammography technology, enabling efficient image quality, storage, and retrieval. And the tomosynthesis capability, similar to the other two devices, it provides 3D functionality, offering improved visualization for breast tissue and enhancing diagnostic accuracy. And lastly, patient comfort. The device includes features like the Hologic Smart Curve system, aside to provide a more comfortable mammography experience by reducing breast discomfort and pain during compression. Based on this evolution and comparison that I did, the GE sonograph Pristina stand out as the primary choice due to its superior image quality, low radiation dose, and digital mammography capabilities, 3D functionality, and emphasis on patient comfort. The Siemens Mammoth Revelation and Hologic Selena Dimension System serve as backup choices, offering comparable imaging quality and digital mammography capabilities, but with some limitation in the 3D functionality capability and patient comfort features. Lastly, to our summary of the device. Breast imaging is critical component of healthcare, and selecting the right mammography equipment is initial for accurate diagnosis and patient care. In this presentation, we have discussed the important features needed for mammography equipment, provided a tender document with technical specification, and outlined our decision-making process based on device comparisons. By following these guidelines, we aim to make an informed, precise discussion that meets the needs of our local hospital and ensures the highest quality of breast imaging services. Thank you for listening, and I will hand that to my friend Muhammad Gashkari.
Assalamu alaikum. This is a report on fluoroscopic device purchasement for King Abdullah Hospital. This report outlines the process and consideration taken in selecting a new fluoroscope device for King Abdulaziz Hospital. It includes a detailed analysis on essential features of the fluoroscopes, a tender document for vendors, and decision matrix based on offers from various vendors, and this is guided by the ECRI institution device comparison. It is done by Muhammad Al-Kashkari for the class of imaging. Going to the next slide. Introduction. Fluoroscopy is a key diagnostic and interventional tool in modern healthcare. King Abdulaziz Hospital commitment to patient care and accurate diagnosis necessitates the acquisition of state-of-the-art fluoroscopy device. This report details the criteria and decision-making process for this purchasement. King Abdullah Hospital wants to buy a new device of a fluoroscopy, but they wanted to be the best of them all. So in this presentation, we will see which one was the best. Important features and justification. The important features are image quality, radiation dose management, system flexibility and versatile, user-friendly interference, and maintenance and support. Image quality has high resolution image and are critical for accurate diagnosis and successful inventions. Radiation dose management, minimizing radiation exposure, is essential for patient safety, especially for frequent or vulnerable patients. System flexibility and versatile. A versatile system can be employed for various procedures, enhancing the device utility and cost effectiveness. User-friendly interference simplifies operation and reduces the likelihood of user error, leading to more efficient patient throughput. Maintenance and support ensure the long-term reliability and performance of the equipment. Tender document for vendors. Comprehensive document. The tender document is created outlining the technical specification required for the fluoroscopy device. The document includes the above listed features that we listed before this one and safety standards to which vendors must adhere. Vendors offer analysis and decisions. First, we got the primary device. The primary device A selected for its superior performance in key areas such as image quality, dose management, and system integration. We got backup device 1, which is device B. It's a strong contender with excellent user interference and support, but slightly lacking in system flexibility. And lastly, we got device C, offers good general performance but has limitation in integration and space efficiency. Evaluation criteria and rating. We evaluated the criteria and rating based on the features we listed above. These features we listed the three devices and then we rated them. So for image quality we got 5, for management we got 4, system flexibility we also got 4, user interference we got 4, maintenance we got 3, system integration we got 5, footprint and mobility we got 3. So for device A we got 28 out of 35. Device B we also got 28 out of 35. But in device C we got 26 out of 35. This shows that device A and device B are both at the same level, but each one of them has a better feature than the other one. Like in device A, excels in image quality and system integration, but has average mobility and maintenance support. In device B, offers an excellent user interface and maintenance support, but falls short in radiation dose management and system integration. Device C is highly mobile and has good dose management, but its image quality and system flexibility are comparatively lower. In conclusion, this shows that device A and B are both most favorable option, where they both scored 28 out of 35, offering a balance of high-quality imaging, system integration, and user interference. This goes back to what the hospital needs more. If the hospital needs image quality and system integration more than maintenance and stuff like that, they should go with device A. If they need maintenance and they care more about reliability of the device, easy setup of the device, they should go with device B. Device C is scoring 26 out of 35. This doesn't take device C out. Device C is a strong contender, especially in terms of mobility and radiation safety. The final decision will depend on prioritizing the criteria most critical to the hospital need. We're gonna go to the most critical hospital need and we're gonna pick that device. Thank you.
Assalamu alaikum. Hello everyone, I'm Yazid Al-Zahir. Today I will continue presenting our purchase decision, but now it will be for the fifth medical device, which is the scanning system computed tomograph. In this presentation, I will talk about three main parts as follows. First, list of the most important features required for the hospital with their justifications briefly. Second, the needed specifications. Lastly, decision-making process. So let's begin with the list of the features. Well, our list was about the CT scanning system, and it must have the following features. First, high quality imaging features like high spatial resolution and low noise levels for precise diagnosis and treatment planning. Second, it should also have quicker scanning times and efficient workflow to reduce patient wait times. Third, it should also have dose reduction features to reduce radiation exposure without compromising image quality. Next, it should also have multi-slice capability for quicker scanning and better visualization of anatomical structures. Then the system should incorporate advanced applications to enhance diagnostic options and enhance hospital capabilities. Lastly, it should also have an intuitive interface for easy operations for the healthcare providers. Next, I would like to talk about our list needed for the specifications. So they are as follows. First, CT scanning system brand and model. Then detector rows number such as 64, 128 and so on. Third, current range and tube voltage speed of maximum scan. After that, maximum gantry rotation time. Then maximum table weight capacity. Lastly, weight of the system and dimensions. After that, or lastly, the decision making process that we have done were as follows. For these three main steps in order to decide the purchase for the scanning system CT. First step, obtaining offers from suppliers by asking for proposals from various suppliers in accordance with the guidelines in the seller document. Second, looking at device comparisons by contrasting the seller offers with the requirements listed in the seller document or the datasheet. So thinking about things like picture quality, speed and effectiveness, lowering the radiation exposure, easy of use, and service and support, and so on. Last step, sorting the options as a certain order, like primary and backup choices, based on the specifications and the device comparisons. As a result, we have decided to obtain the primary choice as Philips Brilliance 16, while the backup choice was for Toshiba Aquilion 16.
In the end, we have done our purchase decision making of 5 medical imaging devices for a local hospital. These devices were as follows: first, scanning system or ultrasonic imaging; next, nuclear tomographic imaging; third, breast imaging, mammography; after that, fluoroscopy; lastly, scanning system or CT. By providing their list of features, specifications, and evaluation as for the process of decision, and we provided for all of these devices their primary and backup choices. So please, if you have any question, please email me at my official email, and thank you all for your listening.